Hello students, welcome to GradeBooster. Today our lesson is metals and non-metals. In this lesson, we are going to discuss about metals and non-metals, their physical properties, their chemical properties and their reactivity, how they react with different substances and how metals are extracted from the natural minerals. So these are the different things that we are going to discuss in this lesson. This is a very important lesson from class 10 chemistry. So children, before we proceed into the lesson, if you have not subscribed to our channel, please subscribe to GradeBooster and please give a like and please share this video with your friends, right? So let us get into the topic. First, we are going to begin with the physical properties of metals and non-metals. First, we are going to begin with the physical properties of metals and non-metals. So, first we are going to talk about the metals, right? So, what are the physical properties of metals? Metals, we all know about metals. We are all using a lot of metals, right? See in your home, whatever the gates for your compound, the compound gate or grills for your windows, see they are made up of iron. So like that there are so many metals. You go to kitchen, in your kitchen utensils are made out of different metals. Some are made out of brass, some are made out of steel, some are made out of copper and copper bottom and aluminium, like this. So we find metals everywhere. We use them in our day-to-day life. The bike you are traveling and the car you are traveling or the bus you are traveling is made out of different metals. So metals are a part of our life. And every day we are observing their physical properties. The same thing here we are learning in the textbook. See, what are they? Metals are generally solid. Usually metals are solids except mercury. Mercury is in liquid form, but rest of the metals are solid. Metals are hard. Yes, metals are hard. That's the reason why if you want to make a hard thing to hit something like hammer or something, you make it with a metal. Metals are hard. Okay. Metals are lustrous. Lustrous means metals will have a luster. That means a glow, right? So metals, they have a glow. They have a shiny appearance. That is luster. Luster. That is called as luster. And they are lustrous and malleable. Metals are malleable. Malleable means we can make the metals into thin sheets. Thin sheets. Metals can be made into thin sheets. They can be beaten into sheets. That property is called as malleability. Malleability. Okay? Malleability. The gold is made into gold sheets. Silver is made into silver sheets. Right? So copper is made into copper sheets. All these are metals can be made into sheets. So that nature of the metal is called as malleability. So next it is ductile. The other property is ductility. Metals can be drawn into wires, right? Metals can be drawn into wires. Copper wire, silver wire, gold also can be drawn into wires. So most of the metals can be drawn into wires. This property is called as ductility. Ductility. That is ductile. So metals are good conductors of heat and electricity. Metals are good conductors of heat and electricity. So these are the main physical properties. So what else? Metals have high melting points and boiling points. If you take some metal, if you heat it, it won't melt easily, right? So you are taking some water in a bowl and heating it on the stove. Water is boiling, the metal is not boiling because the metal's boiling point is far higher than the water. Water boils at 100 degrees, but the metal, it do not boil at 100 degrees. Its melting point is far higher. So they have high melting point and high boiling point, right? So that is the another property of metals. And metals have a property called sonorous. Metals are sonorous. They have a property called as sonority. They have a property called as sonority. What is this sonority? So sonority means when the metals are hit, they gives out a ringing sound. That is the reason bells are made out of metal, whether it is a temple bell or a church bell, right? So school bell, all these are made out of metals, which give this ringing sound. So when they are hit, they produce a ringing sound. So that property is called as sonority. What is that called as? Sonority. So metals are sonorous. Yeah, they produce ringing sound. And one more property is that metals are dense and heavy. Metals are dense and heavy. So metal objects easily they sink in the water, they drown in the water because they are heavy. Their density is high, much compared with the water. So metals are heavy and they are more denser. So what are the examples of metals? Iron, copper, aluminum, zinc, silver, gold, all these are metals. Okay. Sodium, that is also metal. Potassium is also a metal. Let us look at the picture. The same properties what we have discussed here, the same properties are given here in the picture. You can see the ductility, that means the metal can be drawn into wires, and malleability, that means the metals can be beaten into sheets, they can be made into sheets. That property is called as malleability. And metals have a shiny appearance called as luster. Luster is the other property. And solidity, metals are heavy and dense, and metals are good conductors of electricity as well as heat. Since the metals are good conductors of heat, we are using metal vessels to cook the food because they are the good conductors of heat. Metal is used as wires in electric circuits because metal is a good conductor of electricity. So metals are good conductors of electricity as well as heat. Right, children? So we have discussed their important properties, the physical properties of metals here. In this slide, we discussed about metals, physical properties of metals. Now let us see what are the physical properties of non-metals. Now we talk about non-metals. Let me change the pen color. All right, non-metals. Non-metals are usually soft and dull. But how are the metals? Hard and shiny. These are soft and dull. Here there are some exceptions, except diamond. Why? Diamond is a non-metal, but it is very hard and shiny. So in this property, it is not accepting. Okay, there is an exemption. It's not matching with the properties of the non-metals. Diamond is a non-metal, but usually, why here it is given usually? Usually means most of the cases. Usually means most of the cases, the non-metals are soft and dull in appearance. So, non-metals are usually soft and dull in appearance, and the other property is non-metals are brittle. They are brittle. What is this brittleness? Say for example, you are holding a steel glass tumbler in your hand, steel, and another glass tumbler is made out of glass. Glass tumbler, steel tumbler. So you left both the things down onto the floor. You dropped them. What happens? The glass tumbler, as soon as it hits the floor, it shatters. It breaks. Whereas the steel tumbler, when it falls down, it won't break. Right? Of course, it may get a small dent, but it won't break. Right, children? Because the difference is glass is brittle. Glass is brittle. Whereas this steel is, it is not brittle. Right? So, non-metals are brittle in nature. If you leave a non-metal, if it hits something, it breaks. It can be easily breakable. That is the brittleness. They appears to be hard, but they can be easily breakable. That is the brittleness. And next, they are non-malleable. That means you cannot make them into sheets. Metals are malleable. You can make them into sheets. You can beat them into sheets. But non-metals, you cannot beat them into sheets because they are non-malleable. That is the property of non-metal. They are brittle, they are non-malleable. And they are non-ductile. That means you cannot make the non-metal into wires. You cannot, okay? But with metals, we can make a metal into wire, but non-metals, we cannot make them into wires. So they are non-ductile, non-malleable, brittle. Non-metals are poor conductors of heat and electricity. Heat and electricity, except graphite. Here is an exception. Graphite is a good conductor of electricity. But rest of, that is the reason usually, mostly, most of these non-metals are poor conductors of heat and electricity. They do not conduct heat and electricity, so that they are very poor conductors. They do not conduct heat and electricity, whereas the metals are good conductors of heat and electricity. Now, density. Metals are dense and heavy. Non-metals are having the low density and low melting point, low boiling point. Metals have high melting point, high boiling point. Non-metals have low melting point, low boiling point. So now examples of non-metals: sulfur, phosphorus, oxygen and carbon. These are the examples of non-metals. Here in the picture we can see they are the bad conductors of electricity, non-metals, and dullness. They don't look shiny, they are soft and dull, and they are brittle. Okay, they have the softness. They are the poor conductors of electricity and heat. They have low density and low melting point and low boiling point. All these are the physical properties of non-metals. Physical properties of non-metals. So, children, we have seen the physical properties of metals and physical properties of non-metals. Next. Yeah. So, what are the exemptions? We have seen the properties of metals and non-metals, but there are some exemptions. What are they? Mercury. Mercury is a metal. Usually metals are hard and solids, but mercury is a liquid. It is a metal, even then it is a liquid. That is one exemption. Second thing, iodine. What is iodine? Iodine is a non-metal. Usually non-metals are dull. Non-metals are soft and dull. But iodine is shiny. It is having the luster. It is lustrous. Iodine is having that shine. That is the exemption. These are all exemptions. Okay. Exemption to the properties, physical properties. Graphite. Graphite is a non-metal, but it is a good conductor. Graphite is a non-metal, but still it is a good conductor. Sodium and potassium, these are the metals. Metals are hard and heavy, but sodium and potassium are soft. They can be cut with a knife. Here in the picture you can see someone is cutting a piece of sodium with a knife. Okay. So, sodium is soft. And this is graphite is a good conductor. Iodine, see, it is having the shining. It is a non-metal, but still it is having the shining luster. And mercury is a metal that exists in the form of a liquid. These are the exemptions, children. Exemptions, right? Usually they do not comply with the properties of metals and non-metals. They have some exemptions. So other properties, usual properties or general properties of metals and non-metals we have seen. So those properties do not apply to these cases like mercury, iodine, graphite, sodium. These are all exemptions, right? Next. Now the chemical properties. We finished the physical properties of metals and non-metals. Now we have entered into the chemical properties of metals and non-metals. So in these chemical properties, the first chemical property that we are going to discuss is reaction with oxygen. The first one is reaction with oxygen. So when a metal reacts with oxygen, what happens? It forms that metal oxide. Metal plus oxygen forms metal oxide. For example, sodium is a metal. Sodium reacts with oxygen. It forms sodium oxide. That is a metal oxide. Sodium reacts with oxygen, forms sodium oxide, metal oxide. In the same way, magnesium is a metal. It reacts with oxygen and it forms magnesium oxide, metal oxide. Metal plus oxygen, metal oxide. This is the reaction of oxygen with metals. So what are the properties of this metal oxide? So here, children, we learned that when metal reacts with oxygen, it forms metal oxide. Okay. So we are not ending there. We are learning the property of this metal oxide. What is this metal oxide? What are its properties? Let us see. Metal oxides are mostly basic in nature. They are alkaline in nature, basic in nature, in the sense they are alkaline in nature. What are alkaline in nature? Metal oxides. What is a metal oxide here? Magnesium oxide. Okay. So we have that in chemical reactions also. We have this burning a magnesium ribbon. If you take a piece of magnesium and if you burn it over Bunsen burner, it burns with a dazzling white flame, like some kind of pencils we burn in Diwali crackers. With a dazzling white flame, the magnesium burns. That means it reacts with the oxygen and it produces an oxide called as magnesium oxide. After the magnesium ribbon is burnt, you will get some white color ash. That is nothing but magnesium oxide. That means magnesium reacts with oxygen and forms magnesium oxide. A metal reacts with oxygen and forms metal oxide. Now we are seeing the properties of metal oxides. So the metal oxides are basic in nature. Mostly they are basic in nature. So we are learning the properties of metal oxides. Now we are going to learn the properties of metal oxides. So what is a metal oxide? When metal react with oxygen, it forms metal oxide. Most of the metal oxides are basic in nature. That means they are alkaline in nature. Okay? Most of the metal oxides are alkaline in nature, basic in nature. But some, mostly they are basic, but some like aluminum oxide and zinc oxide, these are amphoteric in nature. They are amphoteric, both ways. That means they can either react with acids or they can either react with bases. What are they? They are the aluminum oxide and zinc oxide. These two oxides are amphoteric in nature, that you have to remember. Okay? So they react with both acids and bases. But mostly metal oxides are basic in nature. That is the first point that you have to remember. Now let us see, aluminum oxide reacts with HCl. So these metal oxides, when they react with acid, what happens? A metal acid, when react with acid, it forms a salt, aluminum chloride, and water. Salt and water are formed. So when a metal oxide reacts with acid, it forms salt and water. The same metal oxide, aluminum oxide, the same metal oxide, when it reacts with a base, strong base, sodium hydroxide is a base, HCl is an acid. The same Al2O3, aluminum oxide, metal oxide, if it reacts with HCl, means an acid, metal oxide plus acid, what formed? A salt and water. The same metal oxide with base, this time base, sodium hydroxide, metal oxide, base, it forms a salt, sodium aluminum oxide and water. Right, children? So this is the reactivity of metal oxides. So here we are not only studying about metals, we are studying about metal oxides also. How the metal oxide is formed? When a metal reacts with oxygen, it forms the metal oxide. Okay. Now let us see non-metals. Non-metals also react with oxygen, not only metals. Non-metals also react with oxygen. When a non-metal reacts with oxygen, it forms non-metallic oxides. When metal react with oxygen, metallic oxide. When non-metal react with oxygen, non-metallic oxide. What is the example? So what is the example? Example, carbon. Carbon is a non-metal, react with oxygen, it produces carbon dioxide. So non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. When a non-metal react with oxygen, it forms non-metallic oxide. When metal react with oxygen, it forms metallic oxides. Right, children? Okay. So now let us see the next. Reaction with water. First, what we have seen, reaction with oxygen. Now what we are going to see, reaction with water. So metals react with water also. And what do they form? They form metal hydroxide and hydrogen gas. When metal reacted with oxygen, they form metal oxide. When metal react with water, they form metal hydroxide, metal hydroxides. That is the difference. What are the examples? Sodium is a metal. It reacted with water, metal plus water, metal hydroxides, that is sodium hydroxide, plus hydrogen gas is released. Okay. Another example, calcium is a metal. Yes, calcium is a metal. It reacts with water, calcium plus water, metal plus water, metal hydroxide, that is calcium hydroxide and H2O. Okay. Right. So some metals, they react even with cold water, but some metals, they react with hot water. Okay. So which metals are reacting with cold water? Sodium, potassium, calcium, they have high reactivity. They are highly reactive. Sodium, potassium, calcium, they are reacting even with cold water. See children, just if you take some sodium metal, pure sodium metal, and if you throw the sodium metal in water, it burns and splashes, right? It catches the fire. That means it is highly reactive with water, sodium, right? See, it is reacting even with the cold water. That much reactive the sodium metal is. So some metals, they react even with cold water. Some metals react with hot water or steam. What are they? Magnesium, zinc and iron, they react with the hot water or steam. So iron plus hot water, iron plus hot water. One kind of iron oxide is formed and hydrogen gas is formed. Okay. So hydrogen gas is formed. So copper, silver and gold do not react with water. Copper, silver, gold, they are least reactive or unreactive metals. So they do not react with water. But whereas metals like sodium, potassium and calcium highly reactive with water. Okay. So non-metals do not react with water. Usually they do not react with water, non-metals. But metals are reacting with water. So the second chemical property is reaction with water we have seen. The first one is reaction with oxygen. Next, reaction with acids. We have seen with oxygen, with water, now with acids. So the same thing we have learnt in acid basis lesson also. Because in acid basis we learnt how acids react with metals, how acids react with non-metals, like that. Right. The same topic here we are studying from the side of metals. There we studied from the side of acids in that chapter. Now here, do metals react with acid? Metals react with acids. It's clearly given here. Metals react with acids. Yes, metals react with acids. Yeah. When they react, what do they form? They form two things, salt and hydrogen. Metals react with acids and form salt and hydrogen. Okay. Example, zinc is a metal. HCl is an acid. In a beaker we have taken some HCl and we added some zinc pieces. The zinc, HCl reacts together. They form a salt called as zinc chloride. They form a salt called as zinc chloride plus hydrogen gas. Plus hydrogen gas is released. Zinc, HCl, zinc chloride, hydrogen gas is released. So when a metal reacts with an acid, it forms a salt and hydrogen gas. That you have to remember. Now the hydrogen gas test. Okay, whatever the gas released in this reaction, by understanding this equation we can say this is hydrogen. Just by looking at the equation I can say hydrogen gas is released. But whatever the gas released during the reaction, how do you test it? How do you prove that it is hydrogen? Okay, see here we have an experimental setup. Here is a conical flask, in that HCl and zinc pieces are there. So we dropped some zinc pieces and there is some reaction, you can see some bubbles are evolving, some gas, and here there is a cork and there is a bent pipe through which the gas is escaping. So the gas is captured. What gas is that? We know it's hydrogen. How do we prove it? Just if you take a burning splint or any matchstick over there, so if it gives a pop sound, it blasts and creates a pop sound, it is hydrogen, because hydrogen is highly inflammable. Okay, so brings a burning splint near the gas, produces pop sound. It indicates the gas produced in this reaction is hydrogen. When you mix a metal and an acid, it produces a salt and hydrogen gas. Metals like copper, mercury, silver do not react with dilute acids. They do not react with dilute acids. Metals like copper, mercury and silver. So non-metals generally do not react with acids. Non-metals do not react with generally. Children, wherever you find generally means, of course there may be some exceptions in one or two cases. Okay. So that is why they use the thing like generally, usually means mostly. Non-metals generally do not react with acids. So this is all about the reaction with acids. We have seen reaction with oxygen, reaction with water, now reaction with acids. Next we are going to see reaction with bases. This is the fourth one, reaction with bases. So non-metals react with strong bases like sodium hydroxide. Okay. Some metals react with strong bases like sodium hydroxide. So what do they form? They form a salt and hydrogen gas, just like how it was happened in acids. In acids, metal reacted with acid and it formed salt and hydrogen gas. Here, metal reacting with base, metal reacting with a strong base, producing salt and hydrogen. But all metals do not react with the bases. That is why given some metals react with strong base. Okay. Some metals react with strong base. You have to remember this. Not all metals, some metals react with not always bases, strong bases like sodium hydroxide. Examples: aluminium. Aluminium reacts with sodium hydroxide, and produces water, and sodium aluminium hydroxide is formed and hydrogen gas is liberated out. Then what about non-metals? Do they react with the bases? No. Non-metals do not react with bases. But some metals react with strong bases like sodium hydroxide. Aluminium react with sodium hydroxide and it forms sodium aluminium hydroxide plus hydrogen gas. So this is about the reaction with bases. So we have seen the reaction of metals and non-metals: reaction with oxygen, reaction with water, reaction with acid, reaction with bases. Right, children? Next we have the reactivity series. So what is this reactivity series? So all metals do not react in the same way. Okay. So they have a difference in their reactivity, in the level of reactivity. Some metals are highly reactive, some metals are least reactive or non-reactive. So depending on this, here we have a list of metals in decreasing order. So here we have an arrangement of metals in decreasing order of their reactivity. Based on their reactivity, they are arranged in decreasing order. So the highly reactive ones are in the beginning: potassium, sodium, calcium, magnesium, aluminium. Right. So zinc, iron, lead. Okay, these are the medium reactive. We can say that these four are highly reactive. These are medium reactive. Hydrogen is kept for the comparison purpose. Actually, it is not a metal, but here we are writing hydrogen for the comparison purpose. And copper, mercury, and silver and gold, these are least reactive or non-reactive. Potassium and sodium are most reactive, react even with cold water. Already we discussed it. Sodium and potassium, they react even with cold water. Just if you drop a small bit of sodium in water, it reacts vigorously and produces lot of heat, fire splashes. So exothermic reaction of sodium with water is exothermic. So these metals like potassium and sodium are most reactive even with cold water. Okay. So that's why we are writing them in the beginning. Gold and silver are least reactive, found in free state. Gold and silver are least reactive. That is the reason when they are found in the earth minerals, they are mostly found in the free state because their reaction with the other materials is very less. They are least reactive, gold and silver. Okay. Now, how do metals and non-metals react? How do metals and non-metals react? Do metals and non-metals react together? Yes. Okay. How do they react? So what kind of bonding they form? Let us look at metals. Metals, they have 1, 2 or 3 electrons in their outermost shells. Metals usually have 1 or 2 or 3. Here we have an example of magnesium. Here we have a metal. Let us see how many electrons are there in the outer shell. 2. Magnesium has got 2 electrons in the outer shell. So metals usually have either 1 or 2 or 3 electrons. So to get the stability, to attain the stability, to form a bond, they lose the electrons and they become positive ions or cations. By losing electrons, they become positive ions or cations. Okay. So they lose electrons to form positive ions or cations. Example, for example, sodium. By losing electrons, it becomes Na plus. Magnesium, by losing electrons, it becomes Mg plus. Okay. That is the case of metals. Metals, by losing electrons, they become positive ions, okay, or cations. Non-metals, they have 4 to 7 electrons in their outer shell. Chlorine, 7. 1, 2, 3, 4, 5, 6, 7. 7 electrons in the outer shell. Chlorine is a non-metal. So non-metals usually have 4 to 7 electrons in their outer shells. So they cannot lose 4 or 7 electrons. So what do? They gain electrons. They gain electrons to form negative ions or anions. They gain electrons and becomes negative ions or anions. Okay, anion, minus anion. Why it is minus? Because it is taking some electrons, gaining electrons. Metals are giving out electrons and becoming positive or cations. Right, children? So in this way the metals and non-metals react. So when a bond is formed between a metal and a non-metal, the transaction of electrons takes place. Who is giving the electrons? Metals. Who is taking the electrons? Non-metals. Next, formation of ionic bonds, ionic compounds. So how an ionic compound is formed? Right. So ionic compounds are also called as electrovalent compounds. Okay. Ionic compounds are also called as electrovalent compounds. So here we have a metal atom and non-metal. Now a bond is going to be formed between these two, sodium and chloride, metal and non-metal. So here the metal donates the electrons, sodium is donating the electron, this electron belongs to sodium here. So now the chlorine has taken one electron, so it became anion. Sodium has given one electron, it became cation, positive charge. So now the bond formed between these two is ionic bond. It is ionic bond, okay, or electrovalent bond, because here donation and acception of electrons took place. Who donated? Sodium given. Who has taken? Chlorine. Okay. So example, sodium chloride, NaCl, the common salt. Sodium by giving the electron it becomes Na plus, and okay, chlorine by taking the electron it becomes Cl minus. So it forms NaCl. Right, children? Okay. So this is the example of ionic bond. Next, properties of ionic compounds. The compounds that are formed by ionic bonds are called ionic compounds. The best example is sodium chloride, salt. It is an ionic compound. So what are the common properties of ionic compounds? So in carbon compound lesson, we studied the properties of covalent compounds, because the carbon compounds, in that carbon compounds, they form different compounds by making the covalent bond. But here ionic bonds are formed. Okay, we are talking about ionic compounds that are formed by ionic bonds. First one is formed by transfer of electrons. Okay, ionic compounds are formed by the transfer of electrons. Covalent bonds, sharing of electrons in carbon compounds. So there the case was sharing of electrons. Here transfer of electrons. From sodium to chlorine, electron is transferred. Second one, have strong electrostatic force of attraction. In this bond, strong electrostatic force of attraction. Sodium and chlorine, strong force of attraction. What kind of attraction it is? Electrostatic force. Okay, electrostatic force, because of that opposite electric poles. Right, that's why the ionic bonds are strong compared to covalent bonds. Ionic bonds are strong. That is that ionic compounds are having high melting point compared to covalent compound. So they have high melting point and boiling point because the bonds are so strong. Right, when you compare ionic bond and covalent bond, ionic bond salt, covalent bond sugar, which one melts fast? Sugar melts fast. Right, salt do not melt fast. Melting point of salt is very high. Right, so melting point of sugar is less. So high melting point, ionic compounds have high melting point, high boiling point. Ionic compounds are soluble in water, insoluble in organic solvents. Salt, it is soluble in water, so ionic compounds are soluble in water. And ionic compounds are insoluble in inorganic solvents. Sorry, they are insoluble in organic solvents like kerosene or petrol. You see the salt is not dissolved into that, or oil, the salt is not dissolved. So in organic solvents, these ionic compounds are not dissolved, but in water they are dissolved. So conduct electricity in molten or aqueous state, not in solid form. For example, you take salt, okay. So the solid salt, it do not conduct any electricity. That means it do not conduct electricity in solid form. But aqueous state, that means you mixed the salt in water, the salt water conducts electricity. We use the salt water for electrolysis experiment because it conducts electricity. So the ionic compounds, when they are in liquid form or molten form, they conduct electricity. But when they are in solid form, they do not conduct electricity. Okay. Next, occurrence of metals, that is extraction of metals. From where do we get these metals? How do we get these metals? We came to this topic. Okay. This is extraction of metals. So metals are extracted depending upon their reactivity. We already we have seen that highly reactive, medium reactive, low reactive metals, right? Highly reactive, medium reactive and low reactive. So before we see that how the metals are extracted, let us know some important terms like what is a mineral? Naturally occurring substance containing metal. Mineral means the substance which contain a metal. That means from minerals we can extract the metals, right? Ore means mineral from which metal can be profitably extracted. There is a mineral, but you cannot extract much metal out of it. Okay, that is mineral. But what is ore? You have taken some mineral from which you can extract a metal at good amount, by which you can make a profit. That is ore. Ore means a mineral with high concentration of metals. That is ore. Okay, ore means a mineral with high concentration of metals from which you can extract the metal and get some profit. That is ore. Gong, unwanted impurities like sand and clay mixed with the ore. The ore contains sand, clay and unwanted impurities. All these unwanted impurities are called as gong, right? So in metallurgy, what do? They collect the ore and from that they remove the gong. They separate the waste, sand, clay and all these things, right? So that is that different steps of extraction. So there are some general steps of extraction. Generally they are telling that main steps. Concentration of the ore. First they remove the impurities, gong from the ore, that is concentration of the ore. When some ore is extracted, when some ore is collected, from that the gong is removed. What is gong? Sand and clay and other impurities. Second one, reduction. The metal oxides reduced to metals. The metal oxides are reduced to metals by heating, refining. Third one is, okay, some metal is obtained, but it is not completely pure. They will do that refinement to extract the pure metal out of it. So these are the general steps: concentration of ore, reduction and refining. Next, extraction of metals. Extraction of metals based on the reactivity. How we are going to do with the highly reactive metals? Highly reactive metals like sodium, potassium, sodium, calcium, magnesium, aluminum. These are the highly reactive metals. Okay. So extracted by electrolysis of molten chlorides or oxides. Right, children? Extracted by electrolysis. So highly reactive metals are extracted by electrolysis. So in this method, there is no need of refinement. Finally, you will get the pure metal by doing this. Okay. By following this method, you will get the pure metal. You need not do any other steps. Directly this electrolytic extraction helps you to get the pure metal. For example, sodium chloride. By electrolysis, you will get sodium and chlorine. At cathode, you will get sodium. At anode, you will get chlorine. In this way, you can easily separate. Okay. So what is this method? Electrolysis. Okay. So highly reactive metals like potassium, sodium, calcium, magnesium, aluminum can be extracted by electrolytic extraction. Okay. Right. So in this case, we are getting the pure metal. We are getting the pure metal. Further refinement is not needed. Now, moderately reactive metals like zinc, iron, lead, copper, these are the moderately. They are extracted by reduction with carbon or carbon monoxide. So they are extracted. First process is reduction. Okay, right. So the moderately reactive metals are extracted by two methods. Okay, they are by roasting and calcination. So usually these are the two methods, roasting and calcination. These are the two methods mostly used for the extraction of moderately reactive metals. Roasting is usually used for sulfide ores. Okay. Sulfide ores. Right, I'll be writing it again. Sulfide ores. I'll write. Okay. So now calcination is used for carbonate ores. Okay. So calcination is used. So by these methods, moderately reactive metals like zinc, iron, lead, copper are extracted. For example, first they are reduced to metal oxides. The ores are reduced to metal oxides. Then the metal oxides are reduced to metal. Zinc oxide reacted with carbon. So extracted by reduction with carbon or carbon monoxide. Zinc oxide is reacted with carbon to form zinc plus carbon monoxide. In this way, the moderately reactive metals are extracted. How the least reactive metals like mercury, copper and silver, gold are extracted? How the least reactive metals are extracted? They are found in native state. So least reactive metals are mostly found in native state. Okay. Sometimes they are found in the form of sulfide ores. I already told you sulfide ores means which process is used, roasting is used. So by roasting they are extracted, right? So mercury sulfide, mercury plus sulfur dioxide by roasting method is used. And after that they will be sent for refining of the metals. So these metals are to be refined. Whereas the highly reactive metals, directly they are extracted by electrolysis, so they don't need refinement. But least reactive, medium reactive, they can be refined further to get the pure metal. So next see that refining of metals. So we have seen the extraction of metals. Metals are extracted in three different ways depending upon their reactivity. Highly reactive metals are extracted by electrolytic method. And the medium reactivity metals are extracted by roasting, calcination, and after that, okay, reduction method by reducing into metal oxides and finally to metals. And least reactive metals are also done by roasting and reduction. These are the general methods are used. Okay. So the highly reactive metals, they need not be refined because they are obtained in the pure form. But which are the less reactive, average reactive and less reactive. So the metals are extracted, but they were not pure. Those metals are not pure. So those metals are to be refined, means made pure. How do they make that metals pure? That is by electrolytic refinement. For example, copper. So how do we make the copper pure? By electrolytic refinement. Okay. So electrolytic refining is just electrolysis setup. For example, here we have taken copper. Here we took the electrolyte as copper sulfate solution. So here we took copper sulfate. When the electricity is passed, the pure copper is deposited at the cathode and impure metal is deposited at the anode. Okay. So the pure copper gets deposited at the cathode, right? So the pure copper gets deposited at the cathode in this refinement of metals. So the most common method of refinement is electrolytic refining. Next. So the next we're going to learn about corrosion. The other part of the lesson is, the next part of the lesson is corrosion. What is corrosion? Corrosion is that damage happens to the metals because of the atmospheric changes, atmospheric factors like oxygen and water. So in the atmosphere there is a lot of oxygen and water. Of course there are so many types of gases. So these gases or these substances, they react with the metals over time and they cause some damage. That is called as corrosion. Sometimes acids may cause damage to the metal. Sometimes water may cause damage to the metal. Sometimes oxygen may cause damage to the metal. Right? So the gradual destruction of metal due to reaction with air, moisture or chemicals. Chemicals also can cause corrosion. Moisture or air or some gases present in the air. That is the chemicals. Right? So what are the examples of corrosion? Rusting of iron. Here we can see in the picture. So the iron chain got rusted, because how this rusting happens? Iron plus oxygen plus water. Iron reacts with oxygen and water and forms rust. Tarnishing of silver. See, silver spoons become dark black. That is tarnishing of silver, because the silver, it is reacting with the hydrogen sulfide gas. Silver reacts with hydrogen sulfide gas and becomes black. And green coating of copper. Okay. So due to the moist air and carbon dioxide, because of moist air and carbon dioxide, that green coating forms on the copper. So these are all examples of corrosion. So the metals, they corrode because of the air, water or moisture and chemicals. Right, children? So we see that our gates, our house gates, our school gates, or windows, grills, they get rusted over time. Okay, if they are not properly protected. How they are protected? How the metals are protected from corrosion? What is the preventive steps? What are the preventive steps that we take to protect the metals from corrosion? The prevention of corrosion. How can we prevent it? There are different methods. One is painting or greasing. Second one is galvanization. Third one is alloying. Fourth one is electroplating. These are the four methods to prevent corrosion. First one is painting or greasing. By applying paint mostly to the iron grills, iron gates, we can protect them from rusting. Okay. Second thing is galvanization, that is coating with zinc. Here in the picture you can see this is the galvanization. The iron objects are galvanized, they are coated with zinc, so it gives protection from the corrosion. Third one is alloying. Alloying means mixing of metals. By mixing two different metals, you can prevent corrosion. Okay. So you are going to form a metal which is new, like a new metal you are going to form by mixing two different metals. So that is called as an alloy. It's a homogeneous mixture of two metals. So these alloys are not prone to corrosion. So you can protect a metal from corrosion by alloying, mixing metals to resist corrosion. Fourth one, electroplating. Electroplating means we are going to deposit some metal over another metal to give protection. Just like painting. Painting means some chemical you will apply, some polymer you will apply. But electroplating means using electricity, electric current, you are going to plate, cover something, some other metal over a metal which is prone to corrosion. That is electroplating. Now see, alloys. Let us learn about alloys. Here I told you, in the previous slide I told you, alloys is the mixing of metals to resist corrosion. So alloys are not only made to prevent the corrosion. Alloys are made for different purposes. When we mix two different metals, we will get a metal with good properties, best properties. We can make two different metal combinations to get desired qualities. Like that alloys are made. Let's see what are these alloys. So alloy is a homogeneous mixture of two or more metals or a non-metal. It can be a mixture of two or more metals. It can be a mixture of metals and non-metal even. You can mix some non-metal also to make an alloy. So why do we make alloys? To improve hardness. To improve hardness. I told you, alloys are not only to prevent corrosion. There are other benefits also. What are they? To improve hardness, to increase the strength, to make them corrosion resistant, to make them corrosion resistant. For all these purposes, we make alloys. What are different alloys? Brass, bronze, solder, steel, stainless steel, amalgam. Okay. How this brass is made? By mixing copper and zinc. What are the uses? Brass items are used for cooking, decoration, and okay, some instruments. Most of the puja samagri, okay, those who perform pujas, puja bells and okay, diyas and all made out of brass. Brass is made out of copper and zinc. Bronze, copper plus tin. Copper plus tin. By mixing copper and tin, we can make bronze. They are used in coins, making coins and statues. Solder. Solder wire is used to attach the two wires in an electronic circuit, soldering. So it is made out of lead and tin, mixing of lead and tin, and it is used for joining wires. Steel, iron and carbon. So carbon is not a metal, it is a non-metal. Iron plus carbon, they make the steel which is used for tools and machines, to make the machines, parts of machines, tools. Stainless steel, it is an alloy. It is made by mixing iron, chromium, nickel. Stainless steel is having the shiny appearance, stainless steel. Our utensils and okay, cookware and all these okay, kitchenware are made out of stainless steel. That is made by mixing iron, chromium and nickel. So utensils and buildings, for that stainless steel is used. In buildings also the railings are made out of stainless steel, right? Next, amalgam. It is made by mixing mercury and some metal, and it is used for dental filling. So these are all the different alloys and their components and their uses, right? So next. So let's say the key points for quick revision. We studied about metals. Metals are electropositive. Metals are electropositive. That means metals, they give away the electrons and become positive. Cations, they form cations, they are good conductors. Non-metals are electronegative, they form anions, they are the poor conductors. Metal oxides are basic. Metal oxides are basic in nature mostly. Some are amphoteric in nature, they react either with acid or with base. Non-metal oxides are acidic in nature. Okay. So next, reactivity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead. So here we see that the reactivity of these metals decreases. Here the potassium, sodium are highly reactive. When we come okay, down to this lane here, the last ones are least reactive, like silver and gold. This is the reactivity series. So all metals are not having the same level of reactivity. Some are highly reactive, some are moderately reactive, some are least reactive. So next, ionic compounds. So ionic compounds, they have the ionic bonds. So those bonds are formed by transferring of electrons. So they have high melting points because the ionic bonds are stronger than covalent bond. So they have high melting point. They conduct electricity in molten or solution form. Ionic compounds, when they are in solution form, that means aqueous solution form, or in the molten state, they conduct electricity. Ionic compounds do not conduct electricity in solid state. Okay. So corrosion. Corrosion means damage to a metal because of air or water or chemicals. That is corrosion. Corrosion can be prevented by painting or by galvanization or by making alloys or by electroplating. These are the methods to prevent corrosion. So what are alloys? Alloys are the mixture of different metals or metal and non-metal. It can be metal and a non-metal. Alloys are made to get good properties. Okay. For improved properties, alloys are made by mixing different metals. So this is all about the metals and non-metals lesson. I hope I covered everything there. So my idea is to cover all the topics of the lesson in short time, that is around some 30 to 40 minutes of time. Okay. So I'll be coming up again with a much more elaborated version of the same lesson before your boards. But this one short idea is to give you the complete idea of the lesson in less time. I hope you enjoyed the video, you liked this video. So please give it a like and please share this video with your friends and please subscribe to GradeBooster channel. Right? So I'll be coming again with a new video very soon. So till then, stay tuned. Thank you and thanks for watching. Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to GradeBooster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos. Check the end screens for our new videos.